Okay, hi, it is February 5th, 2010, and we are doing sum and difference formulas.
What does that mean?
Wouldn't you like to know? Okay, so, we're still on trig. We're doing sum and difference formulas, okay, of the trig functions. This is one of those things that was absolutely vital back in the day just to find the sine and cosine of certain angles, and it is still needed in calculus to transform functions. Calculus, you perform operations on certain functions, and in sometimes you need to change them from one function to another, right in between placing blue dots on the noses of students. So,
I thought you said it was optional.
no.
Actually,
Okay. That's right, thank you. Okay, so, here's the first formula, and for now, I may go into a little more where these come from later, but for today, on our abbreviated schedule, I'm just going to hand them to you. Like an egg fish.
literally a figurative.
I'm not sure yet.
Is that
Guys,
D or weird?
okay, thank you. All right. Cosine, alpha minus beta. Martina, I may care later where you were, but right now I don't.
She was just talking about some stuff.
I was talking with.
Okay. This symbol is alpha instead of x and y. And this one is beta. And
Is beta just B with a longer tail thing?
seems to be. That's how I always remember to draw it. Okay?
And chalk is
Sort of.
S.
Pardon?
Like there's a thing in German which is like, it's pronounced like a double S and it looks like that.
Okay. I have no idea. At any rate, if you have the cosine of a difference, there's subtraction going on. The formula, and I always double check these, get settled back there and pay attention, is the cosine of the first angle times the cosine of the second angle plus the sine of the first angle times the sine of the second angle. Okay?
Are you sure?
I am sure. I was double checking, but I am sure. To prove that this is true takes more time than we have today. I may go back and prove some of them. Some years I've even had proofs of these be extra credit assignments for kids.
Wait. Is that just like a really fancy D, or is it actually like...
As we discussed right as you were coming in, this is alpha and beta, the first two letters of the Greek alphabet.
Are we gonna ever bring in gamma?
I don't know how to make that letter.
No, because we're not going to do any
What's
triangle
the-
identities.
what's
We use
the
theta
third?
instead of all things.
Oh, that
What's
makes
the third?
The third one would be gamma. Alpha, beta, gamma, delta, epsilon, and then I start losing track.
Oh.
I used to have to use those for my angles. I didn't use theta.
Right, we start, for some reason in America, we start with theta as like x, but then when we get to x and y, we switch to alpha and beta.
Yeah, this is retarded.
Yeah, just an unknown angle. Now, what we have here, here's one quick example of how this is used. Without a calculator, I can now, if you know this, I can ask you to find the cosine of 105 degrees. In this class, this is a totally fair question for the next test with no cheat sheet and no calculator. Because what you know is, so what you got to do is you got to figure out, I'm sorry, I did not mean to do 105 degrees, I apologize. I meant 15. I was doing a sum instead. Cosine of 15 degrees is now totally fair. Here's why. You guys know everything on that chart. You know why you're 30, you're 60, you're 90, etc. On a test in this material, I'm only going to give you angles that you can determine are sums or differences of ones from that chart, or ones you should know from the unit circle. So can you express 15 degrees as a difference between two angles that you should know the cosine of?
30.
30 and what? Lauren?
35 and 20.
I don't know but I don't know the cosines of 35 and 20, so that's not helpful.
30
How about
and
60
you know the cosine of 30.
60 and 45, or 45 and 30. Either one works. Let's do 6. So I can rewrite this as the cosine of 60 minus 45 degrees. Now, remember what I said before. Sines, cosines, etc., they are operators, but they are not one of the four fundamental operations. They are not adding, subtracting, multiplying, and dividing. Order of operations does not apply to finding the sine of an angle. The distributive property does not apply to finding the sine of an angle, nor the tangent, nor logarithms are also in this category. So I can't distribute. I can't say it's the cosine of 60 minus the cosine of 45. It's not that kind of operation. That kind of operation is addition, subtraction, multiplication, and something else, whatever the fourth one I say is. What I can do, though, is apply these formulas. And again, I can draw a big triangle and prove where this comes from, and I may do some of that next week.
Well, what if you have like the, so you're not going to give us one like the cosine of 14 or?
No, if I give you that, that's where you pull out a calculator.
Okay.
All right? But, and again, some of the reason for this is not because you're ever going to be stranded on a desert island and need to know the cosine of 16 degrees. It's going to be because you're going to have, it's going to be because you're going to have to transform a function in calculus into something else. So for this one now, I can make this the cosine of 60 times the cosine of 45
Why would you want
plus
to?
the sine of 60 times the sine of 45.
We have calculators for a reason.
Oh, but now I'm going to take them away from you for a reason. So, the cosine of 60, you all know, is 1/2. The cosine of 45, you all know, is root 2 over 2. The sine of 60, you all know, is root 3 over 2. And the sine of 45, you all know, is root 2 over 2.
Why can't we just use our calculator to find cosine of 16 degrees?
I'll be happy to have that discussion when I have time next week. I will not have it today. So, the square root of 2 over 4 plus the square root of 6 over 4. So my final answer for this is the square root of 2 plus the square root of 6 over 4. And this is the process I'd expect you to use. And again, on your next test, won't give you a chart, won't give you a cheat sheet, and we've got a bunch more of these to learn.
Just like,
That's okay. Any questions on this, though? Did I fill it in correctly? Any questions on what I did?
Wait. Hold on.
no.
Do you guys remember on one of the trig identities, I said I thought I saw a shortcut
Yeah.
to prove it? It's because the trig identity had some things in it that looked like this, and I thought I could change it back. I thought I could use these backwards to speed it up.
Oh, okay.
So this may show up in some trigonometric identity work as well. You have to use these to verify some. Now, I'm going to give you the next one, which is, I want to make sure I write these down correctly, the cosine of alpha plus beta. If you can figure out these patterns, you can use them to help memorize. But the cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta.
That makes sense.
So it's counterintuitive.
I don't like it.
It's cosine cosine, sine sine.